Alright, so this is the third in a series of videos on the viewport assembly. This will be the final one. This is actually where we're going to put all the parts together and finish up with the final viewport assembly itself. So again, going to Schoology, I'm going to go to my day where it says viewport assembly. Click on the viewport assembly PDF file here. Go ahead and open this up and see what I got to get taken care of here. So I've already created this part here and this one here. I see a note at the top says the O-ring is from the toolbox and has an inside diameter 8.225. So we do not have to create this O-ring. So we're going to need to bring the tool for the toolbox. We're going to need an O-ring, and we're going to also need these screw heads right here. Now, what type of screws we're going to use? These are hex head, socket head cap screws. And how do I know that? HX is for hex. SH socket head CS cap screw. Okay, and I would not expect you to know that. So I will walk you through this whole process. So going to SOLIDWORKS, I'm going to do a file new. I'm going to go to one of my other tabs, in this case my tutorial tab, and start with a new assembly and hit OK. Now again, I want to get the first part in there. So I'm going to start by going up to the magic eye here and turning on my origin. At this point, I'm going to bring the base part in. So I'm going to go browse for it, bring in my viewport and say open. I'm going to click right on top of the origin right here and left click. Now I'm going to bring in my other pieces. I'm going to do insert components. I'm going to bring in my acrylic plate, drop that out in front. Now in this case here, I'm going to bring this into a dimetric. I think I'm going to do more of a trimetric just to get a different look. That looks pretty good. Okay, now from here, I'm going to go over to my right. I'm going to click on the books right here called Design Library. I'm going to left click on the toolbox, and under ANSI inch, I'm going to double click that folder. Now what I want to do is I want to start first of all with O-rings. So I'm going to double click an O-ring, go to all O-rings, and there's only one to pick from. We just have to tell it the size. So I'm going to drag this on out here. The size I want to put in there where it says inside diameter, instead of 13.475, I'm going to go to 8.225. Again, I'm looking at that note at the top of the paper. So going up there, I see one that's 8.225 right here. I left click and green check mark. Hit escape because you only need one. And so that one is going to be sitting somewhere right around in here. I'm also going to go in and bring in one socket head cap screw. So again, I'm going into my toolbox. I'm going to go to ANSI inch, bolts and screws, and I'm looking for socket head screws. So I'm looking down here, set screws, set screws, set screws. Here we go, socket head screws. Double click that folder, and I'm looking specifically for socket head cap screw, which will be the third one in this folder right here. Left click and drag one out. Now the size of this, according to our drawing, is going to be 1/4 so I'll show that here. I look down here into this part right here. So it's a 0.25 is 1/4-20. It's going to be 1.5 inches long with 1 inch of threading. The C is for our cosmetic thread. Okay, so I'm going to go back to SOLIDWORKS. I'm going to do 1/4-20 by 1.5 inches long. And the thread length will be 1 inch long, and I'm going to use cosmetic threading. And all cosmetic threading is it makes it look like it is a screw. At this point, I'm going to hit my check mark and call it good. I'm going to hit escape. I'm not bringing 24 of these in. We are going to pattern this in just a second here. I'm going to show you what's called component patterning. All right, do not bring in 24 and have to do 48 different mates. You're going to make a mistake somewhere. Now, what I want to do is I want to start getting this mated together. Now, to do this, I got a couple things I'm going to have to try and get to work here. All right, so I'm going to try my mate. I'm going to hit my O-ring, and I'm going to go ahead and hit the inside of this channel. And what it's going to give me is a tangent mate, which is fine. I can try either way. It doesn't matter. I'm going to go this way, and that gets at least to where that is sitting in that pocket. But the problem is now is it's still not quite in the right spot. Now, I could try to eyeball it in there, but if I move anything, it's not going to get there. Okay, so I got to actually mate this with planes. Okay, so to do that, if you look carefully, this is sitting in the channel, and that's great. Okay, but the problem I have is I got to get this in the right position. So I'm going to have to use my planes with my flyout menu here. So I'm looking at it, I'm going to go to the acrylic plane, or acrylic plate, and expand it. And I'm going to take the top plane of the acrylic plate here. I'm going to go to the O-ring and expand it. And take the top plane, in this case not. I'm going to take the front plane and lock those two together. So now at least it's sitting centered. I'm going to hit my check mark. And then I'm going to take the right plane of my O-ring and my acrylic plate. I'm going to find a matching plane, in this case my right plane of my acrylic plate. And now I have this perfectly set inside. So now my O-ring is sitting perfectly in that groove. At least I think it is. Maybe it's not. I can't tell which way. Yeah, it is. It's sitting right in that groove, right where it's supposed to be. Actually, it's not. I'm on the wrong side. So I'm going to go back to this tangent real quick and flip that over. And is that in the right position? There we go. So I went back and I did the alignment here. So now it should be sitting in the right position, which is in that groove right there. Okay. This is why it's hard to work with acrylic, because it's hard to see where this is actually sitting. Now, one of the things I want to tell you is if you go back to the drawing, we have to still add material to this, because this O-ring right now is a silicone rubber. But if you go back to SOLIDWORKS and look at the O-ring over here to your left, which is right here, there is no material on it. Now you need to change this, because this will throw your mask off. Same with our socket head cap screw. They're chrome stainless steel. If you don't add material on here, it will change this significantly by a pound or two. So I'm going to go in here to Material Not Specified and right click, Edit Material. Now in this case, silicon is under Other Non-Metals. Under Rubber, and it's silicon rubber. Okay, right there. Apply and close. So it turns more like a black. Okay, looks good. All right, now with that, I'm going to go ahead and close this. I'm going to open up my socketed cap screw, because if you look again at the drawing, and again, this is commonly forgotten about, we are given this material of chrome stainless steel. So we have to add that on there. So I got to go back into SOLIDWORKS here, expand this out, and where it says Material Not Specified, right click, Edit Material, go to my steel, and we're looking for chrome stainless steel. Apply and close. Okay, now at this point, I have all my pieces in place. Okay, what I'm going to do now is I'm going to start lining up my holes. All right, so I'm going to take my mate tool, and I'm going to take the inside of that hole there and line it up to the inside of this hole here. Okay, that gives me that part there. Now, this is kind of the hard part to play with this. You got to kind of see that's rotating around. All right, so what I'm going to do next, and really I guess I could take and do this correctly. I don't know if I can make this work or not. Maybe I'll take that edge there and this edge here and make them concentric. And that may actually be the faster way to go, because I think now, yep, so now everything's lined up. Now what I'm going to do, and this is a hard piece of this, is trying to get this face. I got to get that face right there. And this is why sometimes acrylic's really hard. And sometimes I'll go back and change the material to a darker color so I could see it. At this point, I'm going to hit this face here, and now my acrylic plate is pressed up against the metal with the O-ring squeezed in between. So now hopefully it won't leak water. Okay. Now from here, all I'm going to do, go into my isometric view. I'm going to take this shaft of this screw, and I'm going to throw it inside the inside of that hole there. Oh, actually hit the face. See, that's the unfortunate part. So undo that. I'm going to take that right there, and I'm actually going to kind of go inside that hole there. Okay, and I'm going to flip this by flipping that around. Okay. Actually, I'm going to undo that one more time. I don't like that. So I'm going to go one more time here. See if I can get this to line up in one of these spots. All right, I guess I'll go there. Okay, and then I'm going to flip it, and then I'm going to have to kind of somehow reach inside there. And this is the problem. There we go. I'm going to have to drag, let's go ahead and check mark this, but I'm going to have to drag this out the back. Sorry. Okay, now that's almost done. Now here's the hard part. I need this face right here to be flush with the bottom of this face. Now this is where it gets hard, because in this case right now it won't work. So what I'm going to have to do is go to my acrylic plate for a second. I'm going to right click and say remove material just for a second here. I'm going to take it so it goes dark so it's not see-through. And now I'm going to come back and mate this with this face here and that bottom face right there. So now I've got my screw in there. Check mark. I only need one, but I'm going to come back to my acrylic plate now and right click and edit. We're going to go back to plastics and I'm going to put the acrylic back on, apply and close. Okay, sometimes you have to take the material off to make this work. Okay, so I've got this one in here, but I need 24 of these. And I don't want it to play this game of having to mate them 2 times by 24 for 48 total mates. So what I'm going to do instead is I'm going to go to here where it says linear component pattern under my assembly tab. We are going to do a circular component pattern. Now to make this work, I have to have an axis. So I got to come back to the magic eye here, turn on my temporary axes. So what I'm going to do is highlight this first box and I'm going to pick that axis in the middle. Now I want 360 degrees, equal spacing, and I would like 24 of these screws. So the component I want to pattern is going to be simply this screw right here. Now you'll see there are 24 screws in the hole. Hit your check mark, and now you've got everything you need to have this as a finished assembly. I'm going to come back to the magic eye, turn off my temporary axes, and at this point I'm going to do a file save as. I'm going to call this my viewport, final viewport assembly or viewport assembly, underscore my last name, and hit save. Save all. Okay, now if it's asking about the components, usually your screw, I'll do a save as, and I'm just going to save it in the same spot as all my other pieces, so that way they're always together. So I'm going to just hit save. Okay, save as, O-ring, same thing. I'm going to put that in the same spot, so everything stays in the same file, so they're all together. Okay, that makes it safe to when I open it again, I don't have to start looking for parts. Now at this point, I'm just going to do a real quick evaluate mass properties, and I see this thing weighs in grams. Now it shouldn't be in grams because we're doing inches. So I need to come up here to my options button, use custom settings, and change it from grams to pounds, and say OK. So I have it at 35.82 pounds. At this point, go ahead and print your mass properties. Go collect it from the printer and bring it back to your table. And when you have that, go ahead and close out your mass property page. Now, from here, we're going to go ahead and do an exploded view. So under my assembly, I'm going to come on in here and do my exploded view. Okay, now what I'm going to do here is I'm going to use my pullout. It makes it a lot easier if I come in here and left click on the first one here and hold my shift key and highlight all 24 of these. Okay, so again, let me try that one more to show you one more time. Okay, in my exploded view, if I highlight the first one and then shift key and come to the last one, you'll see it populates all 24 so I can pull them all out at the same time. Okay, so at this point, I'm going to pull these all out together, just eyeballing it kind of in place, and that looks pretty good. Now remember, before you move on, and I end up missing one. So let me undo this real quick. Okay, I end up missing this one here. Okay, so there, I just got to make sure I have them all in there. So again, I'm just going to go ahead and grab that Z, pull this out a little bit, let go, and say done. Next thing I'm going to do, I'm going to grab in my acrylic plate. You can do it from your flyout. I'm going to pull this out to about halfway and hit done. I'm going to go to my O-ring right here. Pull that out about halfway. Let go and say done. Now again, it doesn't have to be perfect. It doesn't have to be exactly like mine. In this case, I am going to change this into a dimetric so you can see a little bit better. That looks pretty good. Okay, at this point, I'm going to hit save. Okay, so now all I have to do is put this view here into a drawing. So all I'm going to do is get a GHSA inch, and we're just going to put our exploded view in, add our last little bits here, include the note at the top, and we're going to call this done, and this assignment is complete. So go into SOLIDWORKS. I'm going to go to my GHSA inch. So I'm going to do a file new, SOLIDWORKS templates, GHSA inch, and say OK. Now from here, I'm just going to double click. I'm going to hit my isometric view. Actually, I'll do probably a trimetric view. Look at it real quickly. I'll do it with some black lines. Scale on this will be 1, 2, 3. So I'm going to do a custom scale, user defined. 1, 2, 3. And bring this on out here. I'm actually going to go to a diametric. That looks okay. Let's try an isometric. I'm going to go with the isometric. That looks pretty good right there. Left click and hit my check mark and adjust. Okay. Now, at this point, I'm going to go ahead and start adding in those notes. That includes the one at the top. So I'm going to turn on my node tool. Actually, I'm going to highlight this node over here. Do a control copy, note tool, control V. I'm going to leave that left justified, font size 12. Whoop, I need to highlight all that, sorry. And make it a font size of 12. Click outside of it, put this up in the corner. I may have to lower this down just a little bit, push this back up. Okay, that looks good. Coming down here, I'm going to go ahead and take that title below it, highlight that, control copy, add a note, put it underneath, and control V. Highlight, font size 12, highlight the top line, bold and underline, and then change this to its proper mass, which should be on your page, making sure I get the 2 decimal places and that it is in pounds. That is done. Go to my tables, bill of materials. Okay, click inside here and hit your check mark. Drop your table below. Now I'm going to come in here and kind of clean each one of these pieces up by highlighting, get rid of my last name, just to give myself some space. I got to make this box a little bit smaller. I am going to extend this out a little bit, close this one down a little bit, take my descriptions. Okay, and then at this point, I'm just going to kind of fill in this and then shrink everything down. So I'm just going to go and start double clicking some lines, really kind of tighten this all up to get it all to fit together. Double click the description. First one, the viewport base is 304. I'm just going to put the stainless steel, even though I know it doesn't say that in the material list. Okay, the acrylic plate will be of acrylic. I'm going to call it medium high impact. Or I'm just going to do the medium impact. I want to save some space here. Okay, this will be the O-ring. Silicone rubber. And this right here will be chrome stainless steel. All right, at that point, I'm going to shrink this box down a little bit tighter, shrink down the quantity a little bit tighter, bring this down a little bit lower in this corner, and finish by adding in a title at the top. Double click my BOM table, and we're going to call this Bill of Materials for Viewport Assembly. Okay, and at that point, I'm just going to make a small adjustment up, and that looks good right there. All right, the last part of this, I'm just going to, again, make some small adjustments to this. Looks pretty good there. I'm going to turn on my balloons. I want them at circular, not tight fit. I want them at 2 characters. I'm going to click on each of the pieces. There's number 1. Here's number 2. Acrylic is number 3. Or no, excuse me, that's 2, that's 3. And then I'm just going to pick on 1 screw. I do not need to see 24 arrowheads. At this point, this part is done. I just need to change the title block. So this is 1 of 3. The title of this will be Viewport Assembly. First initial, last name. Today's date. and period, and scale as 1 to 3. So at this point, I'm going to save this drawing, save all, save it as a viewport final assembly, and hit save. And at this point, I want you to go ahead and print. Go ahead and go collect this from the printer, staple the mask properties to the back, and place this in the collection box. At this point, the viewport assembly drawings are done. All 3 should be submitted at this point. Use the videos as you need to get these parts done. Good luck.